Okay, thank you so much. So yeah, essentially, so this is my day job, right? So come down from campus in the evening and having spent the day chatting to my students, working with my students, which is tremendous fun. So it's really fantastic to have a job where you don't actually feel like it's a job. And then you go home and you do a hobby, which also doesn't feel like a job, right? So, so this is going to be, not about my academic work. It's going to be about my hobby. So I'm going to take you on a bit of a journey from the very beginning. So I'm not going to talk immediately about Kagga Kamma. I'm going to talk about the journey that took me to Kagga Kamma. But I think that's important because I don't think Kagga Kamma would have happened if I hadn't gone through all the various stages of this journey. So, so this is kind of my after hours obsession, and it kind of started as a present from my father-in-law, who got me a telescope, and I thought, well, maybe I'll stick a camera on the back of the telescope and start taking pictures. And I very quickly discovered, like I'm sure many of you have, that taking pictures of the night sky isn't so easy, right? So it took me a while to also realize that the telescope that had been given to me was actually the wrong telescope, to begin with at least. So I got rid of it and bought something a lot simpler, a lot more manageable, and got going first with the DSLR and then moving on to CMOS cameras, and the full automated setup that some of us get to play with in the evenings. So it's actually worth sort of pointing, and this is important, it's worth pointing out that only 17% of the world's population live in places free of light pollution. Right. So light pollution is a major problem if you're trying to do astrophotography. And for the most part, I live in a city, most of us living in a city. And if you try and do astrophotography, it's a challenge. It's an even bigger challenge than it would be if you were out in dark skies. So this is kind of the picture that we have globally. Europe is a mess, North America is a mess, Africa is much better, and South Africa is pretty good, provided you stay well away from Cape Town and Durban and Johannesburg. That's those sort of major sort of light generating cities. So the area, the Karoo, Cederberg Mountains is great for astrophotography, and for the most part, provided you're away from towns like Ceres, Citrusdal, Clanwilliam, it's Bortle 1, which is pretty much what you want. Um, so this is the situation where I live. So this is what I was battling with until fairly recently. It's a Bortle 7, probably more like Bortle 8 now. So depending on where you're pointing in the sky, it's either 7 or 8. And if you're trying to do broadband imaging, it takes a lot of effort. You need to gather a lot of data to get anywhere. Narrowband imaging is somewhat better. So for the most part, from Newlands, where I live, I will be doing narrowband imaging. So this all started around probably about 6 or 7 years ago. And what really makes all of this possible is the enormous advances in technology and also filter design and technology and the innovations that have gone into building really excellent filters for astrophotography. So the sort of key areas of major advance has been in photography, clearly, and the CMOS sensors, which really took off once mobile phones had cameras built into them. And that sort of carried across into astrophotography. And now we have cameras which are incredibly sensitive, so much so that you can even do, and I did a project last year with a grade 11 student doing exoplanet transits from Newlands. Okay, and you can only do that because the camera on the back of the telescope was, just amazingly sensitive, to able to do the photometry that's needed to measure the incredibly small dip in brightness of the star due to the transiting planet. So cameras have really advanced tremendously. The other advances have been in automation, so computerization of astrophotography setups, and in terms of processing, now the use of AI to enhance and to make it easier to process data. So these are the sort of major areas where there have been tremendous advances over the last few years in astrophotography, and that really makes the hobby possible. I'm not old enough to remember taking pictures with, with film with a telescope because I wasn't really into the hobby then. But I've spoken to people who would go out with a film camera and take pictures, and you'd have to then wait several days for the film to get processed and see whether there was anything that was worth salvaging from that effort. Now it's much simpler. Um, so just to give you a sort of sense of how things have evolved. So this is David Mallon, who's of course very famous astrophotographer. This is him with the Anglo-Australian telescope, and he's famous for taking the first color images of the night sky. And on the left-hand side is a picture of the Horsehead Nebula taken by him. On the right-hand side, there's a similar sort of composition image I took with an 8-inch RASA. So, this is just in the space of 30 or 40 years, we've gone from something which required I think a 1.2 meter telescope, CCD camera to backyard instrument and Newlands able to capture a very similar quality image. So really amazing how things have progressed. Um, so this was me back in probably about 2017, where I'd basically be setting up my telescopes on my deck outside in above my garden. And with small kids, this was just became too time consuming. It would take more than an hour to set up each night. If you had a string of clear nights, you wanted to use that time. And setting up really, I would just disappear from the family scene for hours on end just to set up. And at some point, my wife said, "This is just not sustainable, right?" So I had to find a better solution for this. So what I came up with at the beginning of COVID was a very simple backyard observatory design, which I constructed in 2020. So just after things started to open up, after lockdown, got a crew in, and they put my design into motion and built a basic roll-off roof observatory on my deck. So that made things a lot simpler. So this was about 2021, roll-off roof observatory in the backyard. And it allowed me essentially to start playing around with automation. So what I wanted to be able to do was essentially not set foot in my backyard observatory and be able to do everything from my sofa in the house next to my wife watching TV, right? So she was happy because I was around to put the kids to bed, and she was happy because I would be sitting next to her watching TV in the evening, right? So, but I'd have a laptop sitting next to me monitoring the activities happening in the observatory. So this whole exercise it got me to learn a lot about automation, and it seeded an idea that if I can do this in Newlands without any intervention, maybe I can do this elsewhere, in maybe hundreds of kilometers away without worrying about issues with weather and things not working. So this was in some sense, without me knowing about it when I started, this became kind of like a prototype for what would develop into KKRO at Kagga Kamma. So here's the kind of automation setup that I had in Newlands, still have in Newlands, although I don't use that observatory anymore. So basically, the roof automation is controlled by an Arduino Uno controller via magnetic sensors, giving basically a roof open, roof closed status. And then because of the height of the roof, and because I needed to park my telescopes horizontally, this required also magnetic sensors on the mounts. So in order for the roof to close, the telescopes needed to be parked correctly. Otherwise, you'd have a situation where the roof would crash into the telescope. So this was actually quite a sophisticated automation system that I had to set up for it to work properly, which would then enable me to sleep through the night and not have to worry about issues regarding weather or the roof closing onto my equipment. So this was quite a nice learning experience. So here is a kind of a little weather station I set up, indicating a transition between clear weather conditions to cloudy conditions, after which the roof would close. So this kind of was great because it gave me the learning experience of setting something like this up, and B, it gave me the confidence to be able to take this concept and move it into the Cederberg and not have to worry too much about the things happening that would endanger the equipment inside the observatory. Um, each of the telescopes in the Newlands Observatory was run by essentially an Intel NUC mini computer. And this is nice because you can basically turn off and on the power on the different devices, the camera, the mount, the focuser, for example. And in this case, with the Eagle computer, you can also toggle on and off the USB controllers. So you can basically recycle, if need be, recycle the USB ports in an automated way. So this can all be done remotely. And in fact, I was using my observatory in Newlands when I would travel to conferences. So I'd go off to say, Norway, and I would then notice there was a clear night in Cape Town, and I'll be able to open up the roof from Norway in the evening at the conference, and give my wife and all my a huge fright. She'd see the roof opening and she'd wonder what was going on. So this again sort of gave me confidence that this could be something which could be operated from anywhere in the world. And that of course is key if you want to run a fully automated remote observatory. Um, the other thing that it allowed me to do was go around schools and do live imaging sessions. So this was I was able to give talks. In this case, this is Parklands College. Went out there in the evening, gave a talk about astronomy and cosmology, and did a live imaging session from the school. So this is the kind of thing that you can do with remote observatories. You don't physically need to be next to your telescope to be able to operate it. And then, a lot of cool things you can do in terms of school outreach, and also school projects like the exoplanet project I did last year. The other sort of project I got involved with some years back was the Cederberg Observatory. So this kind of points towards, it's not that you can't do Bortle 1 imaging. You can take your equipment out to a Bortle 1 site, but you still need to set things up at that site, and you're limited by the fact that you're only at a site like this for a couple of days. So at most you get 2 nights at a Bortle 1 site, and then you have to go home back to Bortle 7. So it's nice to be able to do that, but it's costly. You have to get in your car, drive 3 or 4 hours to the location, set your equipment up, hope for good weather, do the imaging session, and pack up in the morning, and then drive back to Cape Town. So I've been involved in the Cederberg Observatory for a few years now, and it's great because you can kind of mix the sort of visual side of things with the astrophotography. So we've now built in sort of astrophotography sessions into the presentations that we give to the public at the observatory, and also sort of link it in with the visual sessions that we run. So people can basically look at the object through the eyepiece and then transition to a telescope, which is looking at the same object, but through the eyes of a camera. So they can see the quality of the image that you get from the camera and the poor quality of their eyes when they look through the eyepiece. So they get the comparison between what they get visually and also what they get through photographically. The other nice thing about the Cederberg is it's allowed me to sort of bring up students. So we bring up students on a regular basis. They get involved in the public outreach. And they're also now, getting quite interested in getting involved in the Kagga Kamma project as well. And there's a typical evening that we have at the Cederberg during the summer months. We often have 100 people rock up for our open nights. It's really quite amazing. Unfortunately, at the moment, we're closed because during the big storm recently, the major sort of road in got severely washed away, or parts of it got washed away. So we're probably going to be closed until the spring, which is a real shame.
That the one coming from
the N7, yeah.
Algerian.
Yeah, through Algeria up that pass, yeah.
So that's closed.
That's closed. The other route in from the east is fine, but it adds a good hour and a half to the journey, and it becomes impractical driving out just for the one night. So we've decided to close up for a couple of months. And there's of course the famous dome at the Cederberg. So this is me setting up, for an astrophotography session at the Cederberg Observatory. So you set up, you do your imaging session, which is great. It's really nice to sort of operate things, really sort of engage with the telescope and be there on site. But typically I get up there 3 or 4 weekends, where I have good weather, where I can do this kind of thing in the course of a year. So in total, I might get 6 or 7 clear nights at a Bortle 1 site, doing the astrophotography this way. So again, it got me thinking, well, wouldn't it be great having these telescopes located at a Bortle 1 site, and I can then use it pretty much every clear night from my home in Newlands. So here's an image taken from the Cederberg. So, I mean, Bortle 1 sites are fantastic. So this is just a couple of nights from the Cederberg Observatory. And here's another image from the same week that I spent at the Cederberg Observatory. And here's another one. Right, several images. Just run through those. Okay, so as I've said, the problem with astrophotography is that for most people, you're imaging from a Bortle from the city, which is typically Bortle 7 or 8, or even worse. There's a guy in Tokyo. He images, or just on the sort of outside of Tokyo, he images from a Bortle 9 site. So with a few weekends thrown in to dark sites. So you've spent all this money, you bought yourself a fancy astrophotography rig, and you get in Cape Town, maybe you'll get 60, 70 clear nights a year, good clear nights a year, which are relatively moon free, and then a few weekends away to dark sites. So for the investment that you've made in your equipment, you're not really getting bang for your buck, right? So there's got to be a better way. Okay, so the next step is really so Sean over myself, have this vision to kind of try and develop astrotourism in the Western Cape, or make a contribution to the development of astrotourism in the Western Cape. But our focus is very much on building complete online remote dark sky observatories, and Kagga Kamma is the first of its kind in this new journey of ours. So that we've set up a little company called Deep Sky South, and basically the first project that sort of has fallen under this umbrella is the Kagga Kamma Remote Observatory. So there are many things we can do. As I said, the focus is on building remote observatories, but there are other things you can do related to astrophotography, and one is to enable farms in the region to create sort of observing platforms where they might be able to provide a peer to visiting to visitors to that farm who are staying on the accommodation, might have a telescope with them. They can set that telescope up on the pier and do astroimaging. So this has become quite popular in places like Namibia, where there are farms which have done exactly this. They've set up infrastructure which is astrophotography friendly, so the clients, so people can come out, do a bit of sort of do game drives and combine the sort of game experience with astrophotography. So the idea is to provide this kind of expertise for those farms, those locations who want to do something similar in the Western Cape and beyond in South Africa. Of course, sort of astrotourism is not new to the world. It's very well developed in the US. This is, of course, the famous Texas Star Party. And then, of course, the other big development in recent years are the setting up of these gigantic remote observatories. They're more like sort of telescope farms than remote observatories. And of course, the most famous one of the kind is the Starfront Observatory, which I think now has something like 400 telescopes, maybe even more. So they've gone from zero to about 400 telescopes in about 18 months. It really is quite incredible what they've done.
Oh, that's permanently
Yeah. Well, they're permanent. When I say permanent, these are clients who've gone and they've rented a pier, they've sent their equipment out. Telescope has been set up on site, and then they remote in from wherever they live, use that telescope until they finish, their term at the observatory, and then they pack up that telescope and ship it back home.
Okay.
So in some sense, the when I started thinking about remote observatories in South Africa, Starfront had not yet been born. And in fact, the time that was spent trying to find a suitable location for our first remote observatory, in that time, Starfront took off. So, it might have been that we could have been one of the first remote observatories, like this, had we moved a lot faster in the beginning. But it didn't work out that way. But Starfront is a fantastic example of how this whole idea can mushroom very quickly. So I mentioned Namibia. So here is a site in Namibia where this kind of activity is taking place. This is Karapoti. And what they've done is they have a mix of stations where people can bring their equipment and set them up for short periods of time. So they go on holiday, they spend maybe a week at Karapoti, they combine game drives with astro imaging, and then they go home and they process their images once they're back. They've also got so this is a guy who runs a YouTube channel. He went out there a couple of years ago, did few videos of his experience at Karapoti. This is him set up on one of the piers. So basically, what he did was he packed up his small telescope, jumped on a plane with his wife, spent a nice, pleasant week at Karapoti. And in the evenings, while his wife was, sleeping, he would go out to his station and capture images from the pier that he was renting from them. They've also got a little remote observatory there, which you can rent out, but it only houses one telescope. So these are the kind of facilities that currently exist in Southern Africa. They're fairly sort of rudimentary. So what Sean and I came up with was something a little bit more ambitious, where we wanted to build something which would house not just one telescope, but up to 20 to begin with, and then maybe grow to 60 or 80 or even 100 telescopes. So what about South Africa? So the key thing is location, right? So location is key in this game. And I spent about 18 months trying to find a farm that was interested in hosting something like this. So I would drive around on weekends, visit various private game lodges and nature farms and make a pitch, so pitch the idea. And eventually I came up with Kagga Kamma. I went out to Kagga Kamma, and which is a Portal 1 site. So this is basically where Kagga Kamma is located. And I mean, there are many such locations, but it was finding a partner who was keen to develop in this direction. And so I got in touch with Kagga Kamma. They invited me up and to give a presentation to their board, which I did. So this is Kagga Kamma, and went out there, gave a presentation. And the very first question after the presentation was finished was, so when can we start? So they were super keen from right from the very start. So it wasn't it wasn't a difficult sell. So Sean and I, have formed a partnership with Kagga Kamma, and it's a joint partnership. And they, the reason why it works as well as it does is because it is an equal partnership between the farm and the two of us. So that really is what is making the whole thing work very smoothly. So having a good partnership, having a site which has the necessary infrastructure, and that I should say is really key. They have the infrastructure, they have the people on site that can provide support. They have good accommodation. So if you go out there to service the observatory, you can stay in a nice accommodation. There's a restaurant on site, which is nice. So they really have everything that you need to be able to run an operation like this. So it is in the middle of nowhere, but you have the creature comforts on site as well, which is great. So this was the basic design that we came up with. So there was the planning phase where we got in touch with architect and a structural engineer, came up with a plan. And then once the plan was in place and we had a contractor signed up to do the work, things really ran very, very rapidly. We broke ground basically in July of last year, and we were up and running by the end of September. So it really was a very, very fast process. So this is the site. It's about, well, I would say 200 meters to 300 meters from the lodge. So it's easily accessible from the lodge. You can basically walk down from the lodge to the observatory. And this is kind of the whole little video sort of telling the story of the build, which I said, ran incredibly quickly from around about the middle of July through till the middle of September. We were basically good to go. So in terms of the size, this is a 3x8 observatory, so it's 24 square meters of usable space. But as I'll mention a little bit later, we've actually found a sort of quite a ingenious way of increasing the usable space to, from 15 units, which we started off with, to around 20, 21, 22 units that we will eventually have in the observatory. So we probably over-engineered this initial building, and I'm kind of glad for having done it that way because of the storm that we had a few months ago. So the structure was absolutely solid, no issues, no leaks. The roof didn't budge. So probably we spent a little bit more than we needed to on this initial building, but I'm kind of glad that we did. So the building went up and then the piers went in. So this is us putting the piers in. This is the weather station. And then the first couple of telescopes went in. And then this is the first light. Yeah, so that was basically 11th of October, I think, was first light. Here's some other sort of drone shots that we took. So this is from above.
And the power you get from Kagga Kamma.
So power we get from Kagga Kamma. So we have 3 levels of redundancy. There's grid, then they have a solar farm, and then we have a inverter as well in the observatory. So basically, there would have to be a catastrophic failure for things to be a problem. And the way things have been engineered is that if the inverter kicks in, and then after 15 minutes, the roof will automatically close.
Okay.
So there's that built into the workflow as well. So basically, power failure, bad weather, are going to trigger or a communication failure between the controller and the control PC. So those are the 3 areas where things could fail, and in each one of these areas, the roof would close in the case of a failure. So here's another sort of drone shot. So you can see that we have more or less 365-degree horizon. The structure there to the left is actually a putt-putt area. Would you believe it? So in terms of the automation, so this is basically, so when I go in the evening to get things going, this is what I see when I log into the control PC. So we have the weather station giving data on the sky temperature, in other words, whether it's clear or cloudy, or the degree of cloud, rain monitor, wind speed, brightness, humidity, pressure, and so on. Then on the far right, this little sort of box there at the top, that basically is a status giving status on, whether the roof is open or closed, whether there is communication between the Arduino and the control PC, and also power. And then on the left-hand side, that's basically a little script that runs to control the roof. So it opens at sunset, and then provided the weather holds throughout the night, it will then close at sunrise. And if cloud does move in, then the roof it'll trigger a closure event and close the roof. It can be set up so that in the event that the sky clears up again, the roof reopens. So people can, maximize the amount of time that they have available during the course of the night. We also provide a roof status to the users. So basically, users will have a safety monitor on their own rigs, on their own telescope setups, and they will know the status of the roof. So they can basically program their systems in such a way that the roof will open, that the telescopes will start operating when the roof opens, and if the roof closes, then the telescope will park. So we have a client, for example, who basically he doesn't touch. He has his system running 24/7, And he only goes in occasionally to check whether things are still working properly. And it works day in, day out. When the roof opens, the telescope starts operating, starts capturing data. And then when the roof closes, it parks, shuts everything down. And then the next night, telescope starts operating again if the roof is open. And this just keeps on going. And he has basically a list of targets which he's working through. And the data is uploaded to the cloud. And every morning he wakes up and he goes to his computer and he has his data and he can process. And he doesn't even have to look at his telescope. It just runs completely autonomously from one night to the next. So this is a view from the inside, one of the inside cameras. We have not an all sky cam. It's kind of 120-degree view of the night sky. And then we have a website. So if you are interested in checking us out on the website, you can visit the KKRO website. We've got an image gallery, so starting to post images from the observatory on the gallery. And yeah, so how do things work? So basically, if a client will contact us, there are various options open to them, so they can rent out a pier, and what they pay, the monthly rental will depend on what's called the swing diameter of the telescope. So basically, the swing diameter is the distance or the volume that the telescope will sweep out as it moves around during the course of the night. So that will project down onto the ground and give an area that is being used by the telescope, and that will determine the price that the client will pay on a monthly basis. So most of the instruments in the telescope in the observatory are small, sort of 60 to 80 millimeter or 60 to 100 millimeter apochromatic refractors. We have a RASA in there as well. And we've got a 14-inch, Sean's got a 14-inch Celestron Schmidt Cassegrain in there as well, a C14. So that's the biggest telescope that we have in the observatory.
So they actually get the whole setup.
So no, they either send, so there are two models. So either clients will send the equipment to us, we set it up for them, and they just pay for the pier. They rent out the pier on a monthly basis. Or we also offer complete rig rental. So we have 5 telescopes in the observatory, which clients can rent out for a period of time, and then they rent out the entire setup.
Okay.
So it's a complete turnkey setup. They basically get everything. We just provide them with a login, and then they can log in and control the telescope. So we've got 5 telescopes running in that mode. And that's turned out to be actually super popular. We have clients which are renting out, for example, a 61 millimeter telescope for 6 months at a time. So we did experiment very, very briefly with a nightly rental, but after 3 nights of doing this, very, very quickly, people were saying, "Oh, I don't want to rent it for 2 or 3 nights. I want to rent it for 6 months." So we've kind of abandoned the nightly rental model. So these are some of our clients. So most of them have got Instagram accounts. So you can go and check them out. If you just search on Instagram for Kagga Kamma Remote Observatory, a lot of them are tagging or put a reference to KKRO on their Instagram pages, so you can check out what they're doing. And we've also got an incredibly active Discord. So one of the ways we communicate with our clients and the way they get in touch with us and also talk to each other is through Discord. And it's amazing the kind of chit chat that goes on Discord. Night after night, people are chatting about equipment and imaging techniques and processing techniques and sharing their images. It's really quite a nice little community that is starting to build up around the observatory. And most of them, they've all not met each other, so they're all sort of getting to know each other via Discord, but and learning a lot, sharing a lot of information about what they know about the hobby to their colleagues. So these are some more pictures from the observatory. So this was about 2 3 months ago. We weren't quite full then. We are now actually we have one more pier which is going to be filled in August, and then we will be totally full in this building. So these are some of the instruments that we have currently in the observatory. So as you can see, most of them are small APOs, so between 60 millimeters and 100 millimeters. Most of them are fully automated in the sense that they've also included a flat panel. So if they want to take flats in an automated way, they can. So these sort of contraptions at the front of the telescope, these are flat panels. So they can open and close the flat panel, and they can turn turn on the lights, to take flats, control the brightness, so these are completely fully automated systems. Then the new phenomena in the last few months has been the arrival of sea stars, so smart telescopes. So we now have 4 smart telescopes in the observatory. And this is where this additional real estate has sort of come into play. We very, very soon realized that we have a back wall, which is perfect for mounting smart telescopes. So this back wall over here, so you can see what we've done is we've mounted a steel bar, and on that steel bar you can mount these smart telescopes. So we can probably we have 4 up there at the moment. We can get about 8 on that back wall, and we're thinking of mounting another plate which is offset from the wall to mount another further 8 smart telescopes. So that's actually been quite surprising just how much interest there is for these smart telescopes. I mean, they were never designed for remote imaging, but people have become very innovative in terms of getting them to work at a remote location, including using they're called switch bots. So basically, it's a little switch, little button, little remote finger that can turn the smart telescope on and off remotely. So because these smart telescopes aren't designed you can't turn the power on and off, you can't turn them on and off. So people are now using these little switch bots to turn the power of these devices on and off. So this is Sean's C14 there in the bottom left. So that's the sort of current setup at KKRO. So we've got 15 telescopes on the floor. Well, 14 plus there's one more that will go in August, and then we've got the 4 sea stars on the back wall, and that will we've got 2 more coming in the coming months. So I would say that within a month or 2 we'll probably be full on the back wall as well. So these are the sea stars in operation. So you can see this little device here. That's a switch bot. So basically, you can remotely control that little switch from your mobile phone or from your PC from anywhere in the world, and you can turn your sea star on and off using that little device. So you might ask, well, what about the internet? So we rely on a microwave link to a tower. It's actually been remarkably stable, and this is one of our clients, Azar, operating his telescope from a flight from LA to Boston. So he's sitting on the plane with his iPad, logging into his telescope. He was our second, one of our actually our second client, and this is him sitting on the airplane, capturing data. I think this is M33. I think he's capturing. And he actually then came and visited. He took a holiday with his family out and came out to visit us. So this is Sean, me, and Azar. And he's using using the telescope there that he's holding on to there. That's the telescope he's operating. And we have another client coming out in August to set up his telescope. He's actually worked out that it's cheaper for him to jump on an aeroplane with the equipment than pack it up in boxes and ship it out here. So from the US. So he's actually going to come and spend a few days at Kagga Kamma to set his telescope up. So here's some statistics. So basically, so far we've had 256 nights. And of those 256, 205 nights have been clear. So it gives you an idea of, you're getting full use of your equipment. So in the summer months, during the summer, we are looking at probably about 80 to 90% of the nights clear. And winter, currently, we're sitting at about 50% nights clear. So during the course of a full year, I would estimate we're going to get 270 clear nights, I would say. So again, this brings me back to the point. You bought this equipment, and a lot of us, are sitting with telescopes collecting dust in the corner of our sitting rooms. So rather than have it collecting dust, send it out to KKRO and use it 270 nights a year.
Wind, not an issue up there?
Sorry?
Wind?
Good. That's a very good question. So it follows the usual.
Wonderful clear nights.
Yeah, in summer, there's if you know the Cedarburg, the wind patterns. So during the day, it's a bit breezy, and then typically as soon as the sun sets, the wind drops.
Okay.
And then it picks up again in the early morning. In the winter, apart from when you've got the cold fronts coming through, there's no wind at all.
Because here in town, you guys know that yourselves as well.
Yeah.
You put a camera onto a tripod.
Yeah,
and if you have a sturdy tripod, you need to hang 100 kgs on it and keep it reasonably sturdy. So
I see you did put it's a photo of a air conditioner unit.
Yeah, so we got
try and stabilize.
Yeah, so we've got an air con unit which acts also as a dehumidifier as well. So it's got a dehumidifier mode. We're probably going to have to put in a slightly more powerful dehumidifier because now that we're into winter, dew is starting to become a problem, and in the mornings the telescopes are quite wet. So we need a way of getting the equipment dry in a fairly short time. Yeah, so during the summer months we have the aircon running during the day, when the roof is closed, and then in the winter months we've got the dehumidifier running to basically remove any moisture that's accumulated during the night. So here are some images that I've taken, and I've got some that Azar has shot as well. So this is actually a collaboration between me and Azar at the beginning of the year, the Sculptor Galaxy. This is one of Azar's projects. So what's turning out really popular is doing huge mosaics. So this is like I think, a 6 or even an 8 panel mosaic of the LMC. So that's one of the great things about a remote observatory. You can basically, because you've got so much time, you can collect hundreds of hours worth of data. So a lot of our clients are doing big projects. They will spend 2-3 months on a single target and create these fantastic mosaics. So here's one of my images. This is a narrowband image. Even narrowband is, Bortle 1 is so incredibly fantastic. To capture an image like this from Newlands would have taken me 3 months. This took 3 nights. So.
And how many pictures are that you stacked on top of each
So that's probably about 15 hours. So 3 nights, 5 hours a night.
Right.
Yeah. So this is M33. So again, because we've got this fantastic flat horizon all the way around. I mean, the observatory is sitting at about 1,200 meters. So it's on a plateau. So you can shoot targets. Andromeda and M33 although it's very low down, the quality of the data that's coming, even with those targets being so low, is amazing. So this was about 8 hours worth of data, broadband data. So this is another one of Azar's image, the Statue of Liberty Nebula. Again, I think this was a 4-panel mosaic that he took.
And the editing software that you use?
PixInsight.
Photoshop or PixInsight?
PixInsight, yeah. PixInsight, yeah. So yeah, I mean, sunsets are really an incredible time at Kagga Kamma, sunset and sunrise. And one of the great things about going out there is you get to see these fantastic sunsets, and then because we like to maximize the time when we're up there to get the work done, we're generally up at sunrise as well. So here's some sort of images to sort of close off. These are sunset images at the observatory. And this is sunrise. This is actually driving out from Kagga Kamma at sunrise. And this is the full moon setting just as you sort of drop down from the plateau from Kagga Kamma, driving back down towards Ceres on the gravel road. That's the full moon sort of dipping down below the mountains.
Peter, can you combine the light from all the telescopes into one image?
Yeah, so we've started talking about that. As I said, I've done the one collaboration with Azar. That was the one that gave rise to the Sculptor Galaxy image. This one here. So this image here was a collaboration.
Was that just 2 people?
So that was me and Azar. But yeah, in principle, we can all, we pick a target and we could all collaborate. And with 15 telescopes pointing at one target.
You could do a picture at night.
Yeah, not just that, but you can go really, really deep. So you can, and this is something which has become, really popular at Starfront. So if you look at some of the images coming out of Starfront, these are like 300-400 hour projects. Big, huge. Actually, there's a 1,000-hour project I think that they posted recently, and it's because you've got 10 people imaging the same target. So yeah, so I think the possibilities are really exciting with this. So the big question is where now? We're basically full on building 1. We've decided to build a second building. It's going to be double the size, so it's going to be 40 square meters roughly.
In the same area?
In the same area, yeah.
Okay.
At Kagga Kamma. And we started taking bookings already for building 2. So I mean, it's
Good for you.
so I think by the time we build this thing, we'll probably be full on building 2, and then we'll be saying, well, okay, now building 3, right? So we're not going to. I think we don't want to expand to the same, the same extent that Starfront has expanded, because I think that becomes. You don't, that one of the great things about Kagga Kamma has been just the camaraderie between all the clients and us. We all got to know each other, and we're chatting all the time, and everyone's incredibly friendly. And if you sort of expand now to like 200 telescopes, you lose that personal touch. So I think, we're looking at maybe 60, 70 telescopes in total eventually. And then we have it at the level where we get to know all our clients properly, and they're comfortable with leaving their equipment with us. And it's still more of a hobby than a business. I mean, it is a business, but it's um, we prefer it to be more of a hobby than just to make lots of money. Yeah.
Do you have a lights out for the lodge?
Yeah, that's it. So there are some lights which stay on throughout the night, but they are basically covered.
Yeah.
So in fact,
Could they go to red lights like in Copenhagen?
they could. We are talking to them about this. Actually, so if I go. Okay, so this is actually live. So it's actually cloudy tonight. It was actually open earlier, but it's now closed. So this is actually live image. It's the inside camera. So we do have also an outside camera, so I can show you a live stream from. Okay, so this is the reason why it's so bright is the moon's up, right? So it's when the moon is up, it's almost like daytime. And you can see there in the back, this is the lodge. There are some lights, but I mean it's an exaggeration. It's not nearly as bright as this. It's just that the camera is so sensitive.
Every time you grow the number of people with telescopes, the lodge will grow.
No. The lodge they run
And they accommodate a lot of people.
but no, I mean these clients are living in the US and the UK and Scotland, and they're external. So basically their telescopes are here, but they're operating the telescopes from. Yeah. So the only time we've had clients on site, like Azar, he came to visit because he wanted to see the site and have a little holiday in South Africa. And then, the other client that's coming out in August, he'll stay a few days just to set the telescope up, and then he'll leave, and then he'll be operating the telescope from the US.
So where would be the perfect scenario as well, like Kagga Kamma, somewhere else?
Well, we would like to stay at Kagga Kamma, so with building 2 will go up here. But we're not closing the door on other farms approaching us and say, look, we want a remote observatory. We're very happy to talk to them about, forming a partnership and setting something up with them.
I think also if you go too far away from, for lack of a better word, centralized area like Kagga Kamma is, security starts coming into play and all kinds of things.
Yeah, so that's a very important point. So the thing with Kagga Kamma is that it's about a 1 hour gravel road to drive on a gravel road to the nearest tar road. And that's just outside. It's probably another 20 minutes from there on tar to Opterberg. So to get in, it's a bit of a mission, right? So if you're going to try and steal equipment from the observatory, first of all, it's that we have surveillance cameras, right? So it's monitored 24/7. Secondly, okay, now you've gone to the effort of removing one of these telescopes. You've got to know about telescopes to be able to remove them. It's not an easy job to take a telescope like this down and then pack it up. But then you've still got 50 minutes on a gravel road.
Mhm.
By the time you've got to the end of that gravel road, there's going to be security waiting for you. So it's very safe. The drawback of being in a really remote location, of course, is you're limited by relying on a line of sight microwave internet link, which works pretty well, but it's not a gigabit connection. But to get gigabit internet, you need to move close to a town or to a road. If you move close to a town or to a road, then security becomes an issue. So yeah, it's yeah. So yeah.
Are all those telescopes mounted with cameras, or are there anyone with spectrographs or even solar telescopes for daytime?
No solar, no spectrographs yet.
Yeah.
We have some interest from a group in Japan who want to send something a lot bigger, a bigger instrument. Actually, they want to send 2 instruments. But that's going to have to wait for building 2. So they want to do science. So I think I think we'll start to see people, with those sort of interests coming on board. Yeah.
Is yours the first in South Africa?
Yeah, we're the first, yeah.
You're the first.
Yeah.
Because I just wanted to ask, why wouldn't the Japanese, for example, contact the guys at Salt? Wouldn't they do something like that to accommodate equipment for?
Well, SALT is not a private site. It's owned by the state, right? So
Thought been additional income for them.
it could be, yeah.
Well, they have all those, most of the observatories now, they've got 12 people who are active.
Okay.
But they're all university and science
Right,
groups.
yeah.
So you can see here, this is my so if I log in, so this is me connecting now to the control system. So then I just basically log in. So you can see it was clear earlier this evening, and then it sort of became cloudy at what point at that point the roof closed. And it's probably going to be cloudy for pretty much the whole night, I think, tonight. So that's the control system. So that's basically what I see from home. This is how and I just together with I mean, together with a live feed. So basically, this is the camera, so I can see what's happening live, and then I can, yeah.
And being the Cederberg, I presume there's no air pollution at all?
Not really, no.
Nothing.
It's a beautiful area. Yeah.
How much dust do you have?
Yeah. So we do get a bit of we've mitigated against it. We have sort of put some rubber seals on the to cover the gaps, but we still do get a bit of dust coming in. But the on-site staff, they come in every so often to dust to basically clean the telescopes. Not the optics, but just the outside. But yeah, there is a bit of dust. But you're going to get dust whether you're at Kagga Kamma or in Cape Town. There's always going to be dust.
Maybe on the wood with the wind, you're gonna have dust.
It's
Yeah, we could,
Well,
hats off to you,
everything
Really.
is sand there, so.
incredible.
Yeah, there's a bit of sand.
the
There's
grouping can be quite strong. so it
yeah,
doesn't-
yeah. No, we get, in that we do get winds up to, on an average summer day, they can get up to 20, 30 kilometers an hour. I mean, right now, if you check, right now the wind speed is 0, right? But it's cloudy, so
It's winter.
um,
what did the wind reach in the recent storm?
oh, it was over 100.
Wow.
Yeah. No, we were. I was traveling. I was in China, and we were all stressing a bit. Um, because the forecast had predicted winds up to 120, 130. And I was in touch with our structural engineer, and I said, what would you say the maximum wind speed? And he said, probably about 100, 120.
So that
So
picture in the top right there was your screensaver on your laptop for a while, was it?
so I was watching that storm come in, and yeah. But I think it can withstand winds fast, stronger than 120. I think, given what we experienced, and just watching, you didn't see the building move, so I mean it was solid.
The rounded structure that you have
Yeah,
will
yeah.
let the wind flow over it
Yeah.
much easier than
Yeah.
having
Yeah.
rigid edges,
Yeah. So yeah, it's solid. It's pretty solid. So I'm not too concerned about the weather. Instagram.
All on Instagram.
All on Instagram, yeah. I mean, it was amazing. I mean, literally, once we were, in fact, even before the building was finished, we had people signing up. So we would send them pictures of Azar, for example. We would send Azar pictures every week of how things were progressing. And then as soon as we were operational, basically, he rented out one of our telescopes and was up and running. So yeah. So there was a lot of interest, and then people talk. So one of our clients runs a YouTube channel, Naz Astronomy. So he's just recently done an interview with me and Sean, which will get aired, I think, next week. So through his networking, we've picked up clients. And then the last peer has been taken by, do you know the Astro Imaging channel in the US? Run by a lady called Molly and Daniel and a few other people. And I think it's monthly. It's a monthly show that they run, have a big following in the US, and they're going to be renting the last pier in the observatory. So they're going to probably give us quite a lot of promotion through that contact.
So nothing through the universities.
No. This is basically this is the hobby. Yeah. So this is
Well done.
Yeah.
yeah.
Thank you very much, Peter. There were some questions online which Sean has answered, so.
Oh, has he? Okay,
yes,
cool. Thanks,
you very
Sean.
much for that. So,
Do you want to? Can Sean speak, or can he go?
yeah,
Do you want to say something, Sean?
Your speaker.
He's going to make coffee.
Sorry, I needed to find the
No, it's
microphone.
sound is on. Yeah.
The microphone switch quickly. Yeah, so there's been a number of
He's
questions
just finished
around.
moving down from Joburg. So he's
Then can you hear me now?
down now permanently, which is great.
Talking, but we don't hear you.
Yeah.
So there's something
Can you hear me?
No, we can't hear you, Sean, but it's fine. Don't worry.
Can you hear me? Okay, no problem. Thanks, everybody.
You showed your home setup. I know that you've got a cursed oak tree which blocks your vision.
No, it basically due north. Yeah, it basically blocks. It's right where the meridian is. So
has it got shock ball beetle yet?
good question. I don't know. But the thing is, I'm not
Will
using.
it last forever?
I'm not using my. I mean, it's basically there is a telescope in it,
I think
but I haven't used it in 3 months.
I think
There's no
Newlands has got an outbreak of shock ball
Has it?
beetle. But,
I'll have to check. Yeah.
I see at your home observatory there was a photo with, is it the fireplace?
There's also
Is that yours?
that's mine. Yeah, but it's
so
a pellet fire. It doesn't cause any problems. It doesn't.
Okay.
And usually, you know, when I was imaging from there, I would have the fire off. So it's. But as I said, I haven't used since October last year. I haven't used it. You know why? Why? You know. So I don't know what I'm going to do. I'm probably going to take it down and maybe move it somewhere else.
Building number 3, Kagga Kamma.
Just have a little personal 2 or 3 telescopes in there. Yeah, but that served its purpose. It was a great learning experience, and I think most importantly, it gave me the confidence. I think if I'd done this, having not done the Newlands Observatory, I would have been very nervous about the client equipment, my equipment. But I'm pretty confident that, you know, there's not much that can go wrong. I mean, that's.
So where is your camera in?
So the camera, there are 2 cameras. There's one outside. This is the outside camera.
No,
You're
your
talking
telescope.
about.
Oh, my telescopes. Okay, so my telescopes, I'll show you. So this one is one of mine that's being rented out. This one, it's the same one actually. Is it? Yeah, it's the same one. This, it's on the next slide, I think. Yeah. This is a Spree 100mm, and this is mine. This is the one I use for my own imaging. And then this one I'm renting out as well. So here's a nice example of a telescope with a fully automated flat panel front. And then and the Rasa as well. That's my scope, but we're going to rent that out as well fairly soon. I'm just we want to move it to a shorter pier because of wind. So even if there is a breeze, because it's sitting quite high up on that pier, it does catch the wind a little bit.
How deep do those piers go into the ground?
We have a concrete slab, and basically it's bolted in with chemical anchors.
Okay.
Yeah.
Okay, thank you very much. Peter, thank you.
Thank you. Thanks very much.